Alright, in this video here we're going to talk about phase, the phases of some sine functions, just basically doing an example problem. So if you haven't seen the other video that I did, where I did the definitions of phase and phase difference and whether two curves are in phase or out of phase, definitely you should check out that video before you watch that one, before you watch this one, so that you understand what we're talking about here. So for this one there, I've given three curves, y1, y2, and y3, and you can see by looking at the equations, they're all pretty similar to each other. Right, they all have the same amplitude of 10. Right, the amplitude is that number in front of the sine function. All three of those share the same amplitude of 10. In order for curves to be in phase, they all have to have the same amplitude. They all have to have the same period. Right, so all of these have the same amplitude of 10. They all have the same period of 2 pi over 3. Now, where I got that from, if you go back to what we talked about, if you watch the videos that I did on the graphs of sine functions, the number multiplying the variable, which in all of these is a 3 that's multiplying the variable, the period is 2 pi divided by that number. Right? Normally the period of the sine function is 2 pi, but if there's a number multiplying the variable, that 2 pi gets divided by that number to make the new period. Right? So the period of each one of these is 2 pi over 3. Right? So since all three of these curves have the same amplitude, they all have the same period, there's a chance that they might all be in phase, or maybe two of them are in phase and the other one's out of phase. So that's what we're going to check here. So the first one are y1 and y2 in phase. Right? Well, if I want to know if they're in phase, I need to first find the phase of each one of those. Now the phase, when I have the sine function in this form, the phase is a number that's being added or subtracted here at the end inside of the sine function, inside those parentheses. Right? And it's the opposite sign of what you see, just like when you're doing horizontal shifts of the graph for sine and cosine functions, or for any function really. But the minus pi over 6 means the phase of y1 is pi over 6. And the 3t minus pi over 2 in y2 tells me the phase of y2 is pi over 2. Right, so that's the phase of each of those curves, each of those sine functions. Right, so that's just the number that we have there. And then if I want to tell if they're in phase, I have to find the phase difference, which, as the name implies, is the difference between the two phases. And what determines whether those two waves are in phase or out of phase is if the phase difference is a multiple of 2 pi. All right, so my phase difference here, and let me just put it down here so I can reach it easier. The phase difference, which I'm just going to abbreviate phase diff, I do pi over 2 minus pi over 6. And it doesn't really matter which one you subtract from which, because it doesn't matter if our answer comes out positive or negative. Right, so pi over 2 minus pi over 6, well, in order to subtract fractions, I need to find a common denominator, right, which I have a 6 here and a 2 here. If I multiply the 2 times 3, it's going to give me 6. So I multiply the top and bottom of that first fraction by 3, so I'm going to get 3 pi over 6 minus pi over 6, which equals 3 pi minus 1 pi is going to be 2 pi over 6. But then I can simplify the 2 over 6, right? 2 goes into 2 once, 2 goes into 6 3 times, so I end up with pi over 3. Right, so the phase difference between y1 and y2 is pi over 3. All right, so that's our phase difference. You just locate the phase of each one just right from the equations, and then you subtract those two and get your difference. And if you didn't understand what I was doing here with the common denominators and all that stuff, go back and watch the videos that I did about adding and subtracting fractions and how to find common denominators, where I kind of walk through that in a lot more detail. All right, so there's our phase difference. Now, if these two are in phase, the phase difference would be a multiple of 2 pi. If it's not a multiple of 2 pi, they're out of phase. Now, the multiples of 2 pi would be like 0, 2 pi, 4 pi, 6 pi, negative 2 pi, negative 4 pi, and so on. Right, so is pi over 3, the phase difference of these two curves, is pi over 3 a multiple of 2 pi? It's not. Right, so y1 and y2 are not in phase, they are out of phase. Right, because their phase difference is not a multiple of 2 pi. And the reason we compare it to 2 pi, or a multiple of 2 pi, is because for the regular sine function, the most basic sine function, the period of that is just 2 pi. Right, so I check to see if my phase difference is 2 pi, or a multiple of 2 pi, and if it is, that means my waves are in phase, which means like the graphs overlap each other. Right, they actually are the same graph. Right, so y1 and y2 are out of phase. Okay? So that's that first part. Let me erase all this stuff. And then we're going to look at y1 and y3. Are those in phase or out of phase? All right, so y1 and y3. and I'm not going to write in phase. Just understand I'm asking the same question here, but now for the two different curves, y1 and y3. All right, so for y1, my phase, once again, is that pi over 6. All right, so that's my phase for y1. For y3, I have that plus 23 pi over 6. So the phase for y3 is going to be negative 23 pi over 6, right? Remember, the phase is the opposite sign of what you see in here. Just like when we're doing the horizontal shifts, it's the opposite sign. All right, so I got my two phases. I want to find my phase difference. So I'm going to do pi over 6 minus negative 23 pi over 6. Now this one's nice because they have a common denominator already, right? They're both over 6, which means I don't have to do what I did before with the common denominators. I can just go ahead and combine these. And when I have that minus negative, right, remember that double negative makes it a positive, so it's going to be 1 pi plus 23 pi, which is going to be 24 pi over 6. And I can simplify 24 over 6 because 6 goes into 6 one time, 6 goes into 24 four times, and I get 4 pi over 1, which is just 4 pi. Right, so the phase difference between y1 and y3 is 4 pi. Right now, to tell if they're in phase or out of phase, is 4 pi a multiple of 2 pi? Well, it is, right, because 4 pi is 2 pi times 2. That's a multiple of 2 pi, because when I multiply 2 pi times a whole number, I get this answer here, 4 pi. Right, so y1 and y3 are going to be in phase. All right, they are in phase because their phase difference is a multiple of 2 pi. All right, so that's how we can check whether two curves are in phase or out of phase. What I'm going to do now is pause the recording real quick and then get out my calculator and graph these three functions just to show you what the graphs look like when the two waves are in phase and what they look like when they're out of phase. Because with all three of these, we have two of them that are in phase and then the other one's out of phase. So we can kind of see it all by graphing these three right here. So let me pause this real quick and then I'll come back with my calculator. All right, so I got my calculator here. I typed in those three functions into my y1, y2, and y3. All right, so now what I'm going to do is hit the graph button. I also already fixed the window. I checked it to make sure that we would see the graphs correctly here. So there's my y1 is already up there. Now it's drawing the y2. Notice y1 and y2 are out of phase, which means the graphs don't coincide. Now it's graphing y3. Notice that you don't see it drawing y3. Since y3 and y1 are in phase, they're the exact same graph. Right, so we have three different functions graphed here, but we only see two different graphs. Right, so the first one is a graph that had the y1 up there already, then it graphed the y2, which was out of phase. Right, it's close. Remember, look, it has the same amplitude, it has the same period, so it's a similar graph, but it's just offset a little bit. Since the phase difference for y1 and y2 was not a multiple of 2 pi, they didn't quite line up. Like one of them was like offset a little bit. It had a little bit of a horizontal shift from the other one. Right, and you can tell that the pi over 6 and the pi over 2, they're not quite going to the same place. They're close, right, as you can see from the graph, but they're not exactly the same. But then when it graphed the y3, we didn't see anything because the y3, since it's in phase with y1, they're actually the exact same graph. Right, so that's why when we graph those three functions, we only see two. Right, so that's the meaning of being in phase and being out of phase. Two sine curves that are in phase are actually the same exact graph. Right, the functions are slightly different, but the horizontal shift is offset just enough that it matches the period, and then you end up with the exact same graph. All right, so that's an example of finding the phase difference, finding out whether two curves are in phase or out of phase, and then what it looks like on the calculator.